Hi students, good evening. In this video we will discuss about stacks. So what is a stack? So in the last session we discussed about different types of data, what is a data structure and what are the different types of data structures. Here in this video we will discuss about a stack. Here we can call a stack is a linear data structure. A stack is a linear data structure where insertion and deletion are possible at one end. So what is a stack? It is a linear data structure where insertion and deletion are possible at only one end. Here if you observe, one end of the stack is open and the other end of the stack is closed. In stack, the insertion and deletion operations are possible through this open end of the stack. So this open end we call as top of the stack and closed end is called as bottom of the stack. So this insertion and deletion are possible through the open end of the stack. Now, so here the stack data structure, it follows a method called LIFO method, that is last in first out. That is last inserted element will be deleted first. Stack follows a method called LIFO method, that is last in first out. LIFO method it follows. What is the meaning of LIFO? The last inserted element will be deleted first. Now here let us assume that here I want to store one element into the stack because this is the open end. Now from here if you insert, so the first element will be stored in this location. Now I want to store another element into the stack, then here the second element will be stored into the stack. Now I want to insert one more element into the stack, that is 30 I want to insert. Let us assume this will be stored in this location. Now I want to insert one more element, that element will be inserted here. Now I want to insert one more element. From here if you insert, so the topmost element here, that 50 will be stored here. Now I want to insert one more element into the stack. Is it possible now? Because the size of the stack is 5. Now already we have inserted 5 elements, so it is not possible to insert element into the stack because we call this statement as stack is full. If you try to insert, we call it a stack overflow. Stack overflow we call it. Now I want to delete one element from the stack. So deletion is possible from this open end. So when you remove one element from this stack, so which element will be deleted? So this topmost element will be deleted. So I want to remove one more element from the stack. Again this topmost element will be deleted. So similarly, I want to delete one more element. This will be deleted from the stack. So wants to delete one more element, 20 will be deleted. So want to delete one more element, 10 will be deleted from the stack. Now I want to delete one more element from the stack. Is it possible? No. Because why? Because there are no elements in the stack. There are no elements in the stack. Now here if you observe, now tell me how many elements are there in the stack now? 3 elements. Now I want to delete one element from the stack. Tell me which element will be deleted? 30 will be deleted. Now tell me how our program will identify it has to delete 30. So what happens here is, in stacks we use one variable called top. So this top variable, it always points to the topmost element of the stack. In stack we use a variable called stack, we use a variable called top, which always points to the topmost element of the stack, that is, if there are no elements, in stack, top will be at -1. That is, if stack is empty, we call it as empty stack. If stack is empty, top will be at -1. Then if stack is full, then top will be at size -1. If stack is full, top will be at size -1. That is, it will be pointing to last location. If top is pointing to this location, insertion is not possible. In this case, the size of the stack is 5. So if stack is full, top will be at size -1. Now here, initially when there are no elements in the stack, here if you observe, if there are no elements in the stack, the position of top will be -1. If there are no elements in the stack, the position of top will be -1. That is, it will be at -1. Now whenever we insert the first element, top will be pointing to this location, and one element, any element, example I am taking 10. So one element will be stored in this location. Want to insert one more element, that will be stored in this location. That is, top will be incremented. Want to insert one more element. So let us assume any element you can take. So here I am assuming 30. So top will be incremented. From this what we come to know, that here whenever we insert an element into the stack, the top pointer will be incremented. So whenever we insert an element into the stack, top will be incremented. So that is top plus plus. That is top plus plus. Now I want to delete one element from the stack. Now top is pointing to the topmost location. I want to delete one element. So here this element will be deleted. Now what is the position of top? It will be decremented. That is, whenever you want to insert, top will be incremented, and whenever we want to delete an element, top will be decremented. That is top minus minus. We call it as top minus minus. That is top minus minus. Top will be decremented. That is, whenever we insert, top will be incremented. Whenever we delete, top will be decremented. Then here we have, what are the different operations possible on stack? So the different operations possible on stack are, first one, very important, we call it as push. Second one, pop. Third one, peep. And the fourth one is update. Then fifth we use display. So what is push? Here push means inserting an element into the stack. Inserting an element into the stack is known as push. push. That is push, inserting an element into the stack. Then what is pop? Deleting an element, from stack is known as pop. What is peep? Retrieving an element from stack. That is, retrieving an element from stack is known as peep. Update, modifying an element of stack is known as update. So display, generally we use this function to display elements of stack, So these are the operations possible on stack. Then here we have, so I'll repeat once again, the different operations possible on stack are push, pop, peep, update, display. Okay, now so let us see applications of stacks, where these stacks are used. Here stacks are used in function calls. Unknowingly in our C programming, when we were discussing, we were using functions. Internally their stack is used. That is, it is used for function calls as well as for recursive functions. Stack will be used. And the general applications are converting infix notation to postfix. And the fourth one is evaluation of postfix expression. And the fifth one is parenthesis matching. These are the different applications of stacks. Now here function calls, recursive functions, then we will see the examples for converting infix notation to postfix, evaluation of postfix expression, and parenthesis matching. These are the applications with example we can see. So function calls and recursive functions, internally they will take the help of stacks. These are the applications of stacks. How these function calls will take? Let me explain you with example. Now here, if you observe carefully, here I have a function, so program. So in this program, okay, if we execute, it generates error message because we need to function declarations. Here we need to make the function declarations for void hi, void hello, void bye bye. Then now let us assume that here we have function declarations. Then this is my main program. So from the main I am calling hi function, from hi I am calling hello function, from hello I am calling bye function. Then it jumps to bye and displays the message bye bye. Now can you guess what will be the output for this program? So the output for this program, now let us see. So function calls are the applications of stacks. Now execution of the program starts from main function. Who will call the main function? Operating system. So internally what happens is, whenever an operating system is called, so that OS address will be stored into the stack. So from here the main function will be called. From main again we are calling a function called hi. So whenever, that is when the control jumps from main function to hi function, what happens here is, before jumping the control to this function, it will store the current address from which location it is moving, that is main line number or some address it will store, that is main address will be stored here. From which line, because again when it is returning back it has to go back to the same location, that is the reason it will store the current address. Then from main, the high function has been called, entered into high. From high again we are calling a function called hello. From here control jumps to hello. Before moving to this function hello, this address, the present address of this function, what is that? High line number or address will be stored into the stack. From which function it has been called, that address will be stored into the stack. Then from hello again we are calling a function called by. Then from before jumping to this function, so the address, the present address, what is that? Hello will be stored into the stack. The address of hello will be from where it has been called, that will be stored. Now it executes the function. First it displays the message bye bye. Execution of this function is completed. Now it has to return back. There are three different functions available. Where it has to go? From where the function has been called to that location it will return. How it knows from where it has been called? So what it will do? Once the execution is completed, it will go to the topmost address of the stack. So what is the topmost address? Hello. So this has been called from a function called hello. So this topmost address it will take and it will return back to hello. It will return back to a function called hello. Then this part then executes this message hello will be displayed next. Execution of hello is completed. Now it has to return back. While returning back, where it has to go? Then it will go to the stack. What is the topmost address? High. Then it will take the topmost address from here. Then it will return back to a function called high. Then displays high onto the screen. After displaying high, execution of high is also completed. Now it has to return back. So where it will go? What is the topmost address? Main. It will go to the stack. The topmost address is main. So it returns back to main. Then again execution of main is also completed. Then where it will return back? Operating system. It will return back to the operating system. So this is the application of stack. That is, without unknowingly we have studied in our C language. After execution of the function completes, control returns back to the caller. That is, from where the function has been called to that location it will return back. How it will go? Internally it will take the help of stack. Internally it will take the help of stack. These are the different applications of stack. These are the different applications. Function call is one of the major applications of stacks. Even recursive functions, how it will go back to previous function calls? Internally it will take the help of stacks. Okay, so these are the different applications of stacks. Then again, after the applications of stacks, we have the concept called representation of stack. How the stacks can be represented? So stacks can be represented in two ways. First one using arrays, second one using linked list. First one using arrays and second one using linked list. Here using arrays is static memory allocation. Using arrays is static memory allocation. That is, the size of the stack will be fixed. Static memory allocation. The size will be fixed. Whereas using linked list, we call it as dynamic memory allocation. That is, size of the stack will not be fixed. We can increase the size whenever an element is deleted. We can decrease the size of the stack using linked list. Okay, thank you. In the next video we will discuss operations, the code for the operations, how push will be performed, how pop will be performed, how display will be performed. We'll discuss in the next video along with the code as well as execution also. Thank you. We'll see in next video. If you like the video, please subscribe, like and share to your friends. Thank you.